All right, Algebra 2, welcome to your second video. This is Unit A2 on the fundamental counting principle. In this video, we're going to go through different possibilities, just like we went through different possibilities with permutations and combinations. And we're actually going to use the big P and the big C a little bit later. But we're going to be talking about a different type of possibilities. Let's look at a problem. Example 1 is all about getting dressed. You're getting dressed and you have some different options that you can wear, some different outfits. You've got 3 shirts, like a t-shirt, a polo, and a sweater. You have 2 pants, jeans, and shorts. And 3 shoes to choose from, your pair of Nikes, your Adidas, and your Puma. The question is, how many outfits are possible? To figure this out, we're going to make what's called a tree diagram. The tree diagram lists all the different possibilities that are available to us. So we start, and the 3 shirt possibilities that we could have are t-shirt, polo, and sweater. So we start by listing out all of the different possibilities. Now, the pants. You've got the shirt already picked out. Now we have to pick out the pants. If you're on the t-shirt, you could pick the jeans or the shorts. Same thing with the polo. You've got the same options, jeans or shorts. And finally, with the sweater, you could pick jeans or shorts. Finally, we've got to pick the shoes. You'd have to pick from your Nikes, Adidas, Puma, and each of these are going to have the same shoe options. So all we do is we list out each of the shoe options, for each of the outfits. Okay, so I have all the different outfit combinations listed. Now I've got to figure out how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. There are 18 different possible combinations available to us of different outfits. Now let's take a look at our second example. Example 2 is called making a sandwich. We're going to make a sandwich and we have some different options. We get to pick a bread, a meat, and a cheese. There are 3 breads, white, wheat, and rye. 4 meats, ham, turkey, salami, and bologna. And 2 cheeses, American and provolone. So the question is, how many sandwich possibilities are there? Again, let's make a tree diagram to figure out the different possibilities. So we start out and we know that we're going to have a white bread possibility, we're going to have a wheat bread, and of course a rye bread. And now it's time to list out all of the meats. Now we could write out all the meats, but that's going to take us a lot of time and a lot of work. I'm just going to abbreviate them with the first letter. H, T for turkey, S for salami, B for bologna. Ham, turkey, salami, bologna. Ham, turkey, salami, bologna. And then we've got the 2 cheeses. American and provolone. American and provolone, American and provolone, and you get the idea. So we continue to list it out, and it's all right to use shorthand like this as long as you know what each of your letters stand for. And after I am done writing all of these out, I'll count up how many options we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, here's 20, 21, 22, 23, and 24. I miscounted there. So there are 24 different sandwiches that we could make. Now the fundamental counting principle is something that we can use when our tree diagram starts to get ridiculous like this one does. There's just way too much going on for us to keep track. And if our numbers start getting bigger, it gets more and more difficult to make a tree diagram. So we use what is called the fundamental counting principle. And the fundamental counting principle says, as long as you know the number of options available, you can just multiply them out. In this example, we had 3 breads, 4 meats, and 2 cheeses. And the fundamental counting principle says you are allowed to multiply them out. And if you do, you get 24. The same number that we got using the tree diagram. So when the numbers get really big, it's better for us to use this fundamental counting principle because we can just multiply numbers and we'll get our answer. But remember, you could always make a tree diagram if you want. It just gets a little messy the bigger the numbers. So next example. This one's about a catalog. A shirt company wants to display a picture of every shirt combination in its catalog. There are 5 different shirt styles that have 10 color options and 4 pocket options. How many pictures will be in the catalog? Well, let me take a look. There are 5 shirt styles, there are 10 color options, and 4 pocket options. The fundamental counting principle says that I can multiply the number of options to get the total number possible. So in this case, 5 shirt styles, and 10 color options, and 4 pocket options. And if we were to multiply them together, we'll get the total number available. In this case, it's 200. There would be 200 pictures in this catalog if it had a picture of every different possibility. And that's using the fundamental counting principle. Multiply the options together. You could make a tree diagram, but realize at the end you'll be counting up to 200. It would just be a little too difficult to make one of those. Now, example 4. Just got 2 left to go. Soccer. A soccer team plays with 3 defenders, 5 midfielders, and 3 attackers. The coach has 7 defenders, 10 midfielders, and 6 attackers on his roster. So he could pick from those people to play in the spots. How many different lineups are possible if everyone only plays their position? Well, this sounds like a fundamental counting principle that we'll use. We'll multiply the defender possibilities times the midfielders times the attackers. Now we just have to figure those out. We have 7 defenders on the roster, but I only want 3 of them. So I remember back to what we talked about just the other day with permutations and combinations. Out of the 7, there are 7 possibilities, and I want to choose 3 of them. Since there's no order to this, I know that this is going to be a combination. Out of 7, I'm going to choose 3 of them. With the midfielders, there are 10, and I'm going to choose 5. So that's 10, choose 5. And last but not least, with the attackers. There are 6 attackers. We're going to pick 3. 6, choose 3. Now, if you had a calculator, or you could use the formula, you could figure out these 3 numbers and then multiply them together. For right now, since we don't have a calculator, we're just going to leave it like this. But if we had a calculator, we could multiply them out. Time for our last example, and our last example has to do with lunch. Today's lunch has 4 entree options, 6 sides, and 3 different drinks. A person ordering a combo for $3.95 must choose 1 entree, 2 sides, and 1 drink. So let me copy this down with the different colors. 4 entree options, and they're going to pick 1. 6 sides, they're going to pick 2. 3 drinks to choose from, they're going to choose 1. So this sounds like something that we'd want to use the fundamental counting principle for. We'll multiply entrees times the possibility for sides times the possibility for drinks. And if we multiply those out, we'll get the number of possibilities that are available. So the first one, the entrees. There are 4 and I'm going to choose 1. There's no order in the way that I'm going to choose it. Same thing with the sides. I'm picking 2 out of the 6. There's no order, so that is 6, choose 2. And with the drinks, there are 3 available and I get to pick 1. Multiply these together and that's going to give you the total number of possibilities. If you had a calculator or the formulas, you could then write down how many different possibilities there are for each of the 3, and then you multiply them together. So that's the fundamental counting principle. It says that if you know the number of possibilities, you can multiply them together to get the total number of possibilities. Make sure you remember to look at your WISC checklist to see any of the guiding prompts that are there for this lesson so that you can write your 5 sentences for your summary, write your 2 questions, and then you're all set. Can't wait to talk to you about this in class.